Hello, and welcome to the Sleep with Science. Tonight, we gently drift into the majestic world of waterfalls, those enchanting places where rivers spill and cascade into serene lagoons below. They transform still landscapes into motion, sculpt stone across countless millennia, and fill entire valleys with cool, drifting mist. Waterfalls are living proof that Earth is always changing, always in motion. Cliffs slowly retreat, gorges deepen, and entire ecosystems organize themselves around these powerful and iconic formations. Some waterfalls thunder endlessly throughout the year. Others appear only for a season, then quietly fade back into silence. There are waterfalls born from glaciers, from volcanic landscapes, from shifting earthquakes, and from the slow passage of time itself. If you enjoy these calm and gentle journeys, you are warmly invited to like, subscribe, or share a quiet thought below. It helps other wandering minds find their way here too, one sleepy soul at a time. But for now, there is nothing you need to do except relax. Allow your thoughts to settle as your shoulders gently soften. Let your breathing slow down, becoming deeper and more natural as your mind begins to drift. Together, we will explore these quiet wonders of nature. Let's begin. The tallest waterfall on Earth is Angel Falls in Venezuela. It pours from the edge of Auyan Tepuy, a vast, flat-topped mountain that rises like a towering wall above the forest. The drop is so immense that the falling water often breaks apart before it ever reaches the ground. During dry or windy conditions, the stream can dissolve into drifting spray, floating sideways long before it gathers again into a river. Reaching this place is part of its story. Dense jungle surrounds the Tepuy, and many visitors arrive by river, then continue on foot toward viewpoints carved into the lush green landscape. From far away, the waterfall can appear impossibly thin, like a delicate white thread stitched into the sky. Up close, it becomes something entirely different. It is a reminder that height changes everything. Gravity has time to act, and the air itself becomes part of the fall. Few places reveal scale so clearly or so quietly. Waterfalls are rivers taking a sudden shortcut through gravity. Instead of slowly winding their way around obstacles, a river sometimes meets a sharp edge and simply drops. That drop is not just a dramatic moment. It is a powerful natural machine that transforms height into motion, into heat, into sound, and into drifting mist. The water accelerates rapidly, then crashes into the pool below, sending energy outward in every direction. Over time, that constant impact can carve a hollow into solid rock, deepening the basin at the base. The cliff above begins to weaken. Eventually, sections of rock break away. The river finds a new edge, and the process begins again. This is why waterfalls are rarely permanent features. They are not fixed objects. They are moving events. They migrate. They reshape valleys. They quietly reveal where the landscape is most fragile. When you stand beside a waterfall, you are listening to erosion happening in real time. Victoria Falls is one place where water seems to create its own weather. When the Zambezi River reaches the edge, it does not fall as a single stream. Instead, it spreads into a vast curtain that plunges into a long, narrow gorge. The impact sends spray rising upward in dense, towering clouds, sometimes far above the rim. Local people call it the smoke that thunders, and even before you see the drop, the name already feels true. On certain days, the mist becomes so thick that it cools the air and dampens the ground far from the edge. Sunlight turns that moisture into shifting arcs of color, bright rainbows that appear, fade, and reappear as you move. It feels less like scenery and more like a localized weather system, one that exists only in that single place. In this constant dampness, forest plants thrive. Life gathers wherever the spray allows it to survive. Step just a little farther away, and everything changes again. Iguazu Falls spreads across the landscape in hundreds of separate drops at once. At the border of Argentina and Brazil, the Iguazu River reaches a fractured edge and breaks apart into a vast network of cascades. Instead of one single plunge, the water threads its way through islands and rock shelves, then reunites below in roaring basins. The most famous section is a vast, curved chasm, often called the Devil's Throat, where immense volumes of water funnel into a single churning void. What makes this place so captivating is the sense of scale unfolding in every direction. You can look across and see curtains, veils, and sudden torrents all happening at once. The sound is not a single tone. It is a layered composition, thunder, hiss, and a deep, rolling rumble all blending together. Mist rises from countless impacts, feeding the surrounding rainforest, which feels almost oversized with life. Standing there, you begin to understand how a river can become an entire landscape. Niagara Falls is not the tallest waterfall, but it is relentless. It flows along the Niagara River between Lake Erie and Lake Ontario, and its power comes from sheer volume. A vast watershed feeds it, so the flow rarely feels weak or hesitant. There are three main sections, each with its own character, from the wide American Falls to the sweeping curve of Horseshoe Falls. At night, colored lights often illuminate the water, washing it in soft hues. In winter, ice can cling to the edges, forming a frozen frame around constant motion. People have been drawn to this place for centuries, first for its natural beauty, then for tourism, and later for industry that sought to harness its force. Niagara reminds us that fame does not require extreme height. Consistency itself can be a kind of wonder. Hour after hour, the water keeps pouring, turning a simple drop into one of the most recognizable sounds on Earth. Waterfalls can also grind solid rock into fine sand through the motion of swirling currents. At the base of a waterfall, water does not simply crash and move on. It often spins. The falling stream drives circular currents that trap stones and keep them in motion. As rocks collide, their edges chip away, and tiny grains are slowly shaved off. Over years, this tumbling action can transform large stones into pebbles, then into grit, and eventually into fine sand. In some plunge pools, the motion is so steady that it drills smooth, rounded cavities into the bedrock. These hollow formations are known as potholes, and they can look almost as if they were carved by tools. In a way, they are. The tools are the stones themselves. This grinding process also reshapes the river downstream. The sand becomes sediment, building bars, filling bends, and quietly altering habitats along the way. So a waterfall is not only carving backward into a cliff, it is also creating new material and sending it onward. Each grain begins as solid rock, then is slowly refined by motion and patience. The mist from waterfalls can carry nutrients into nearby forests. A powerful fall throws more than just water into the air. It launches a cloud of tiny droplets, and those droplets can carry dissolved minerals from the river, along with fine particles lifted from the impact zone. When that mist settles onto leaves and soil, it becomes a steady delivery system. Over time, the area surrounding the falls can support rich, vibrant growth that stands out from the drier landscape beyond. In some places, moss coats the rocks like velvet, never fully drying. Ferns and shade-loving plants flourish where they would otherwise struggle to survive. This creates a close and delicate connection between the waterfall and the forest. The water shapes the rock, and the spray shapes the life beside it. Even insects respond to this constant moisture. Small, damp pockets become busy with life, feeding birds and amphibians that depend on them. When you step through the invisible boundary of the spray, you enter a different world, one where the waterfall's influence reaches every surface. A large waterfall can cool the surrounding air like a natural form of refrigeration. When water breaks into countless droplets, it gains surface area, and that matters. Because evaporation draws heat away from the air. Near a powerful fall, this effect can feel like stepping into a cooler space. Moving air adds to it, as the plunging water churns currents that carry cool, damp air outward along the river corridor. On hot days, people gather near waterfalls for the same reason they stand near fans. The difference is that here, the source is pure physics, not machinery. This cooling can subtly shape the environment. Plants sensitive to temperature may survive closer to the falls than anywhere else nearby. Even sound can feel different in cooler, denser air. In this way, a waterfall becomes a small climate engine, powered only by height and flow. It is yet another reminder that a simple drop in elevation can transform an entire place. Some waterfalls roar because air becomes trapped and compressed within the falling water. A waterfall is not just water in motion. It is water pulling air down with it. As the flow breaks into turbulence, bubbles are forced deep into the plunge and squeezed under pressure. Some collapse suddenly, and that rapid change sends vibrations through the water and into the surrounding rock. At the same time, the impact scatters droplets into a storm of spray. Each droplet collides with others and with surfaces below, adding a fine, high-pitched hiss above the deeper rumble. The shape of the cliff plays a role as well. A narrow gorge can reflect sound back toward you, while an open basin allows the roar to spread outward. That is why two waterfalls of similar size can sound completely different. What you hear is physics made audible. The roar itself is energy being released, motion transforming into waves of sound moment by moment. Waterfalls can carve deep plunge pools capable of swallowing enormous boulders. At the base of a powerful fall, the water does not simply splash, it drills. The falling stream strikes the pool and drives strong currents that spin with force. These currents can lift rocks and roll them like tools across the bedrock. A large boulder can tumble, grind, and slam into stone again and again. Over time, this churning acts like a natural hammer and chisel. The basin deepens, becoming a plunge pool. In some places, the pool grows so deep that it appears almost black from above, like dark glass, even when the river upstream runs clear and bright. During floods, the process intensifies. Fresh blocks can be torn from the cliff and thrown into this grinding motion. This is how a waterfall slowly consumes its own foundation and reshapes it. The pool is not just a feature. It is a workshop where the cliff is being dismantled piece by piece. A waterfall can also migrate upstream over time, reshaping entire valleys. This process is known as headward erosion. It begins simply. Falling water undercuts the rock at the base. Eventually, the unsupported edge above collapses. Once that happens, the waterfall shifts slightly upstream. Then the cycle repeats. Over long periods, the waterfall retreats, like a moving bite taken out of the landscape. As it moves, it leaves behind a steep gorge, along with terraces and ledges marking its former positions. The river above adjusts as well. It may become steeper, straighter, or begin cutting into layers it had never reached before. Even smaller side streams can change as the main valley deepens beside them. What begins as a single drop becomes something more, a traveling sculptor shaping the land. If you look at a map of a river canyon, a waterfall can often explain why the entire system has the shape it does. It pulls the landscape toward itself, guiding how the valley evolves. Many famous waterfalls exist because glaciers once carved deep valleys, leaving behind what are known as hanging valleys. During ice ages, massive glaciers filled main valleys and ground them deeper and wider over time. Smaller tributary glaciers joined these systems, but they often did not cut as deeply. When the ice eventually melted, the main valley floor was left far lower than the side valleys. The result is a sudden drop, where a stream flows out of the higher tributary valley and plunges into open space below. Yosemite Valley is a classic example of this. High side valleys send waterfalls cascading down into the much larger glacial trough. Each waterfall becomes a visible clue, a kind of footprint left behind by vanished ice. It tells a story of where glaciers once flowed and how much rock they removed. You do not need a label or explanation to feel it. The geometry itself reveals the history. A hanging valley is, in a way, an unfinished connection between landscapes, and the waterfall is the sound of that mismatch. Some waterfalls disappear seasonally, only to return as if nothing changed. In many regions, the streams that feed waterfalls depend on snowmelt, monsoon rains, or wet seasons that last only part of the year. When the water supply fades, the waterfall can shrink into a thin ribbon or vanish completely, leaving behind bare rock. What feels surprising is how quickly everything can reset. A strong storm upstream can revive the flow within hours, and the dry cliff suddenly becomes alive again with falling water. Some seasonal waterfalls flow over porous ground that absorbs water during dry months, preventing the river from ever reaching the edge. Others rely on temporary channels that form only when water levels rise. These shifts make waterfalls feel alive, not like fixed monuments, but like changing events. They reward timing. Visitors may arrive expecting thunder and find silence instead, then return later to discover an entirely different scene. Waterfalls often begin at what geologists call a nick point, a sudden change in slope. Imagine a river flowing calmly for ages, then suddenly it meets a sharp step in the land. This step can form when tectonic forces lift the ground, when sea levels drop and rivers cut downward to adjust, or when landslides suddenly reshape the channel. Once the river reaches that break, the water accelerates and begins eroding the edge. A small drop forms, then grows. Fast-moving water cuts more aggressively than slow-moving water. The edge becomes undercut, the drop steepens, and what was once a minor ledge becomes a true waterfall. A nick point can travel upstream like a signal moving through the landscape. Follow it, and you are tracing change itself. What appears to be a static scene is often a moving boundary, a quiet frontier of transformation. Hard rock layered over softer rock is one of the most common recipes for creating waterfalls. When a river flows across different types of rock, it behaves like a quiet tester of strength. A harder layer can resist erosion and maintain its shape, while a softer layer beneath it wears away more quickly under the same flow. Over time, the river cuts into the weaker rock, leaving the stronger layer jutting outward like a shelf. Water spills over that shelf, and the waterfall becomes more defined as the lower layer continues to erode. This is why waterfalls often form at boundaries between rock types. You are witnessing a kind of strength contest, frozen into the shape of the land. It also explains why some waterfalls have clean, sharp edges, while others break apart into uneven cascades. The rock itself is deciding the choreography.
In regions where basalt sits above softer sediments, the contrast can be dramatic. A strong, resistant ledge can form, one that persists for centuries. As the softer rock erodes beneath it, the edge begins to overhang. At first, the waterfall may appear stable, as though it has always existed. But hidden processes are already at work. The falling water continues to attack the base, hollowing out the weaker rock behind the curtain. Bit by bit, the cliff retreats underneath the stronger cap. The upper edge begins to extend outward, creating a growing overhang. From above, everything may still appear unchanged, but underneath, support is slowly being removed. This creates a quiet tension, something you can almost feel when standing near the edge. The cliff is no longer simply standing. It is holding itself together under strain. Cracks begin to widen, blocks loosen. Sometimes you can see fresh scars where pieces have already fallen. The overhang becomes a promise that change is coming. Eventually, it collapses. When that happens, the waterfall suddenly shifts upstream again. What falls is not just rock. It is the old position of the waterfall, removed in a single moment. The river immediately finds the new edge behind the collapse, and the cycle continues. This is how waterfalls migrate, not smoothly, but through repeated cycles of carving and sudden breaking. After a collapse, the newly exposed cliff face often looks bright and raw compared to older, weathered rock. Debris may pile into the plunge pool, temporarily altering the sound and the spray. If you return to the same waterfall over decades, you may be witnessing a slow journey made of sudden steps. As waterfalls retreat, they can reveal entirely new layers of rock. It is like watching pages being turned in the earth itself. Layers once hidden behind the cliff become visible, each one holding clues from a different chapter of geological history. In some places, you may see ancient river gravels pressed into stone. or dark layers formed in seas that vanished long ago. Elsewhere, the rock records volcanic eruptions, each flow stacked upon the next like frozen waves. As the waterfall retreats, these layers are revealed in fresh cross-sections, and the story becomes readable, even to an untrained eye. Colors shift from band to band, textures change. Sometimes you can even see lines where erosion prefers to bite more deeply. This is one reason waterfalls attract geologists. They act like natural road cuts, but louder, more dynamic, and constantly renewing themselves. With every step backward, the waterfall redraws the boundary between what is hidden and what is exposed. Some waterfalls carve narrow gorges that seem impossible from above. From a distant viewpoint, a river may look harmless, just a thin ribbon winding through trees. But step closer, and the ground can suddenly drop away into a deep, narrow canyon. Waterfalls create these gorges because they concentrate energy into a small space. The river below becomes steep and fast, cutting downward with focused force. As the waterfall retreats, it leaves behind a trench, sometimes so narrow that sunlight reaches the bottom only briefly. These gorges can feel like secret passageways shaped by a single moving edge. In places like Watkins Glen in New York, small waterfalls have carved winding corridors that almost look handcrafted. But the illusion comes from patience. Water does not need overwhelming force all at once. It needs time, repetition, and a weakness to exploit. The gorge is the footprint of that persistence. It shows that a river can carve downward with surprising precision, as if it had a plan all along. Waterfalls can also preserve small green zones during times of drought. When rain disappears for weeks, many landscapes dry out and begin to struggle. But near some waterfalls, a different story continues. Constant spray keeps the soil damp, coats leaves, and slows the loss of moisture from plants. This creates a small refuge, a place where life can endure while the surrounding land fades. The contrast can be striking. Step a short distance away, and you may find dry grasses and brittle ground. Step back into the mist, and everything feels alive again. The air is wetter. The vegetation looks renewed. These pockets can protect young plants that would otherwise fail. They can shelter insects, which in turn feed birds and small mammals. In dry regions, these micro-refuges can be essential. They preserve diversity until wetter seasons return. They also reveal something deeper. A waterfall is not just something you observe. It is an active force with a measurable reach. The green zone marks the invisible boundary of falling water, even in a year that has forgotten how to rain. Waterfall spray can create delicate rainbows when sunlight meets the drifting mist. A rainbow here is not painted across the sky. It forms right in front of you, built from millions of tiny droplets suspended in the air. Each droplet bends the light, reflects it internally, and sends it back out at a slightly different angle. When you stand in just the right place, the colors suddenly appear. Step slightly to the side, and they fade. Step again, and they return. Near powerful waterfalls, you may even see multiple arcs at once, including faint secondary bands created when light reflects more than once inside the droplets. Photographers often chase these fleeting moments. but you do not need a camera to feel their quiet magic. It is simply physics, behaving in a way that feels almost like wonder. The waterfall provides the droplets, the sun provides the light, and you provide the perfect point of view. In winter, waterfalls can create shifting sculptures of ice. When temperatures remain below freezing, the mist that would normally vanish begins to settle and freeze wherever it lands.
Railings grow thicker overnight. Rock ledges form delicate white edges. Nearby trees can transform into glittering structures, each branch layered with ice like glass. These shapes are not carved by hands. They are built gradually, droplet by droplet, hour by hour. Wind can redirect the spray, causing ice to grow sideways, upward, or into unusual shapes. A brief warm period may soften the outer layer. Then, a cold night freezes it again, locking in a new texture. This is why winter waterfalls rarely look the same twice. The water continues to flow, while the world around it slowly turns into sculpture. It can feel like watching weather become architecture. Some waterfalls even appear frozen, while water still flows within them. From a distance, it may seem as though the waterfall has stopped completely, as if time itself has paused. But up close, you might notice a faint shimmer behind the ice and a muffled sound hinting at hidden motion. The outer layer freezes first because thin sheets and spray lose heat quickly. Once that shell forms, it can act as insulation. Behind it, liquid water continues to flow, protected from the cold by the ice itself. Sometimes, the water finds narrow tunnels within the frozen structure, emerging briefly before disappearing again beneath the surface. This creates a strange, dual state. The waterfall is both solid and moving at the same time. It is a reminder that freezing is not always a simple transformation. It can be layered, complex, with hidden movement continuing beneath stillness. Waterfalls can also generate their own winds. Stand near a large fall, and you may feel air pulling past you, even on a calm day. As water plunges downward, it drags surrounding air with it, like a conveyor pulling everything nearby. This creates a slight vacuum that draws more air toward the drop. At the same time, the impact at the base sends mist rising upward, forming swirling, shifting currents.
This is why spray can drift in unexpected directions, and why the sound seems to wrap around you. The wind is not random. It is shaped by the motion of the waterfall and the structure of the landscape. In narrow canyons, it may feel like a steady current moving toward the drop. In wide open spaces, it can swirl into eddies that make the air feel alive. The force of a large waterfall can even travel into the ground itself. With every impact, energy moves through rock as subtle vibrations. If you stand close enough, you may feel a faint trembling beneath your feet, like distant thunder that you can touch. Sensitive instruments can detect this as a steady seismic hum. It is not an earthquake, but the effect is real. The waterfall becomes a constant rhythm, striking the same place again and again, day and night. During periods of high flow, the impacts grow stronger, and the vibrations shift in tone and intensity. It is a quiet reminder that landscapes are not still. They carry motion through stone. The river is not only shaping the valley, it is making the ground itself feel alive. Waterfalls can be so loud that they erase conversation. The sound is not just volume, it is presence. It fills the space between people. Even if someone stands only a few steps away, words can disappear into the roar. The waterfall occupies the same range of sound that speech depends on. Your mind tries to separate voices from noise, but the rushing water keeps interrupting. This can feel overwhelming, but also strangely peaceful. People begin to speak more quietly, move closer, use gestures, or simply stop talking altogether. Attention shifts away from words and toward sensation, toward rhythm, vibration, and the rise and fall of sound. In this way, a waterfall changes how you experience a place. It replaces conversation with presence. Even animals respond to this effect. Some birds choose nesting sites near loud water, where predators may struggle to hear their calls. A waterfall does not only shape what you see, it shapes what you hear and what you no longer need to say. The sound of falling water is not a single noise. It is a layered composition of many frequencies. Deep tones come from large volumes colliding and resonating through rock and water. Higher tones come from spray, foam, and countless tiny impacts. Between them, shifting sounds emerge from bubbles and turbulence. That is why a waterfall never sounds flat or simple. It feels textured, alive. Its voice changes with flow. After heavy rain, the sound deepens, becoming fuller and more powerful. During low flow, finer details emerge, individual streams, shifting patterns, subtle rhythms. Even within a single hour, wind can reshape the sound by moving the spray. This constant variation gives waterfalls a kind of mood. They do not repeat themselves. They respond to weather, to temperature, to the unseen changes upstream. When you return to a waterfall, you are not visiting the same moment again. You are meeting a familiar place in a different state. And now, as we reach the end of this quiet journey, let the sound of waterfalls linger gently in your mind. Tonight, we have wandered from towering drops to wide, thundering curtains. We followed rivers as they leapt from cliffs, slipped across stone, and dissolved into drifting mist. We saw how waterfalls are shaped by rock and time, by ice and fire, by slow change and sudden events. We visited places where mist feeds life, where sound becomes a steady rhythm, and where the earth quietly reshapes itself moment by moment. There is nothing you need to hold on to. Let it all settle. Imagine a river finding its path without effort, always moving, always releasing. Picture cool air near the water, a soft dampness on stone, and a steady calming pulse of sound that asks nothing from you. If you enjoyed this journey, you might choose to leave a small note, or simply remember the feeling.
And if you are still awake, another story will be waiting for you. You can let it play or save it for another quiet night. For now, allow your shoulders to soften. Let your jaw relax. Let your breathing slow until it feels natural and unforced. The day can rest now. The river will keep flowing, even without you watching. Sleep well, and good night.